Hello everyone, my name is Timothy Lee Grant, and today we are going to be going back over those Leetcode questions that we studied a little while ago. So this is my new method that I'm going to try to learn and become better at Leetcode. So I've been struggling and struggling and struggling and struggling and struggling to improve at all at Leetcode. So I've been trying to, I think it's almost been a year now since I've started trying to learn how to do Leetcode, and it's just not been working, and it's been a little bit frustrating. So I think that I am going to now try a different method. So instead of just trying to solve problems, what I'm going to do is like this. I'm first going to take a topic, okay, and that it comes from here. I'm going to be doing the neat code, the neat code map right here, right? So I'm going to try to learn a topic. And the way that I'm going to do it is I first pick my topic. Okay, cool. Then I go to Leetcode, not neat code, but Leetcode, and I filter by those topics, right? So like this is 2 pointers, and I filter by the topic, and then I pick problems. You can see here I picked one, two, three, four problems. And I looked at it. I tried to solve it for about 15 minutes or whatever. And then I'm like, okay, let me go directly to the answer. And I watch videos and I have a little notebook and I write down every observation that I get. So I try to make any connections. Like, okay, so I just did one, two, three, four problems. All of them are twosome. What did they have in common? What were the common themes in the question? What can tip me off when I read a problem that this is twosome? What? So that's one thing, right? Another thing is fundamentally what kinds, types of problems does twosome lend itself to solve? Okay, so when I see an array, awesome. Here we go. There is twosome is a possible method for solving array problems. Okay, well, is there any connection? Like, what kind of array problems? Oh, okay, well, it is some, I need to find some relationship between one element in an array and another element in an array. That I should be thinking twosome. So that's fundamentally what twosome is doing. And then I came here and I encountered threesome and I wrote in my little notebook. So the twosome or the 2 pointer method doesn't necessarily need to have 2 pointers. It can have 3 pointers, right? So coming up and trying to figure out those commonalities, what, where, how everything can be used, writing it down and explicitly when I'm solving the problems, even though I know the answer, right? Then taking note of where I'm stumbling. And when I was doing the problems, I realized that, oh, I'm actually stumbling a little bit on those off by one errors. So I need to spend some time to actually focus in on that. And so, okay, great. So I pick my 4 problems and I try to study them as much as I can. I did that on Sunday. I did it on Sunday, and today is Wednesday. So I gave myself a couple days now to forget. Now, what I'm going to do is go back to these questions and I'm going to try to solve them again. So I've given my brain some time to forget. Now I'm going to try to remember a little bit and I'm going to see how much I can get. It's, as you notice up there, it is midnight right now. I got off of work today. So I've already done work, and then I also did my project. So I do YouTube videos of both Leetcode and I also do projects, right? Because I'm trying to do both. I'm trying to learn how to obviously improve my skills at Leetcode because you have to do it. And but also trying to actually gain skills as a software engineer, as a back end software engineer. So I do project videos. So I already did my project video for today. So I'm pretty tired already. So I don't know exactly how this is going to go. But we're going to try it, see if we're able to solve it, and then make some observations as we go. And then later on, I think probably Saturday or Friday, whenever it is, I'll be kind of doing it again to reinforce those. So right now we're just going to go through some of these problems and try to see if it's still in my head. So this is kind of the methodology that I'm going to be working with, and hopefully it starts to bear fruit. So I already reset everything. Number 19, remove the nth. Oh, no, I didn't successfully do this problem. That one was not a problem that I successfully completed. That wasn't one of the ones. That's the same one. Okay. So here. Longest palindromic substring. Okay, so this is one of those core problems, the core problems that I solved on Sunday. Okay, so given a string S, return the longest palindromic substring S. So the idea is I want to find a string within a string that is a palindrome. Okay, and what is a palindrome? It is when the word is spelled one way and backwards the same. So like for example here, BAB and BAB, right? So forwards it's BAB, backwards it's BAB. Okay, so thinking, and I already kind of remember how to do it, but I'm trying to just articulate my thought process. So I'm going to have a drink of water first. So 2 pointers. All right, we know that we're going to be using 2 pointers. What kind of problem is this? Well, first I noticed that we have a string. Well, a string is an array. Okay, so it's an array of characters. It's a character array. Okay, so we have an array. And okay, so the question here is, I noticed in my other problems that we are asking the question like, oh, what is the relationship between the letters, right? And we can say in this problem, the relationship between the letters is we kind of want to check if the letters are the same, right? Like forwards and backwards, if they're the same. So there's something to do with this, right? Which shows two pointers. So okay, that gives me some indication. Well, what's the other thing that I realized, especially when I was doing this problem? It was that there's actually 2 kinds of things, or multiple kinds of things. But what I mean by things is methods of moving my pointers. So when I was solving this problem, one of the things that I wrote down is, oh, this is a radiating method of 2 pointers. So, and what I meant by that is 2 pointers can radiate outwards from a centralized location. Another way is like inwards. So like the gravity, they can radiate, or they can gravitate towards each other. So that's another way that 2 pointers can move. Or they can maybe move like this. But when I was studying this problem, that's one of the observations that I made was, hey, 2 pointers, you're able to radiate outwards. That's a valid method of movement for 2 pointers. Okay, so I remember what's going on with this problem is what we're going to do is we're going to do a for loop, okay? And what we're trying to do is find what is the longest substring, right? So what we're able to do is we need to keep track of our current longest substring and just keep going through each element. So what I could do is do B, is that a substring, or is that a palindrome, yes or no? BA, is that a palindrome, yes or no? BAB, is that a palindrome, yes or no? Is that a palindrome? Is that a palindrome? And then ABA, or A, is that a palindrome? Is that a palindrome? Is that a palindrome? Is that a palindrome? So this is O of n, I believe, squared right there. Instead, the two pointers method is we are going to take a look at each element in the array, okay, and then from that as our starting point, okay, I come here and I have this starting point here. I'm going to radiate outwards and determine if it is a palindrome or not. So I guess as I'm even saying this, one of the things, and I don't have my little notebook, but one of the things that I need to investigate is that, okay, well, hold on. I just said that I was checking if something was a palindrome, and I just said that twice, right? Like, so what's the difference between this two pointers version and the other version that I was just comparing as the bad version? So I need to investigate that, and apparently, right, and this is really good. This is why I like writing it out. This is why I like articulating it in some fashion, either in spoken word. For me, I found that writing things out really shines a light when I don't understand something. But now that it happened when I'm doing spoken word as well now, I realized, wait, hold on, maybe I don't understand that concept as good as I should. So, but that's an observation to make. I need to investigate that further. We're going to continue and do this problem. So I'm going to come here and radiate outwards and see, is it a palindrome? The way that I'm going to do that is radiate and say, okay, if I start here, obviously it's a palindrome if it's a one character, right, from my origin. Then I come out here, and both of these two should match, right? So for example, if I'm looking at A, I'm going to put both of my 2 pointers there, and then I'm going to radiate outwards. I'm going to put one there and one there. And both of those should be the same. If they are the same, then I know that those two are palindromes, or that word right there is a palindrome. Okay. So current longest is equal to 0. Current word is equal to just that. Okay, because we need to return the actual palindrome, which is the longest. Okay, so now I'm going to iterate through each of the elements in this string. So for element in S, okay? Do I need to enumerate? So is it okay, index? I'm not sure if I need to do that. I don't even know if I need the element. I don't think I need the element. I think I can just do index in range length of S. I think I only need the index. And I'm just going to call that I because I don't want to write index all the time. Okay. So now I need to radiate outwards. So left is equal to I. Right is equal to I. So they're going to start at the same index of the string, which is just an array. And then I'm going to start radiating outwards. And I can actually even simplify this. Like left, right, or left equals right equals I. Okay. Now I can go while And here is another observation that I made, is I'm doing a while, but I need to make sure that I'm inside my bounds of the array each time I iterate through, right? Okay. So, first I'm going to check while I is greater than or equal to 0. Oh, sorry, not I. While left, right? Because my left is going to come all the way outside. It's going to come here, right? My left and right are both going to be here. Then my left is going to go bam, bam. And then I want it to not check if it's -1. Equal to 0. And right is less than length of s. And I'm going to create that as a variable. So length of s is equal to length of s. Okay. All right. And what? Now this is where we get to actually check if it's a palindrome. Okay. So what we do is we say of left is equal to s of right. So now we're checking, like we're using the left and right pointer as an index and saying, all right, we know that it's within the bounds of the array. It's not outside to the right or outside to the left. So now we check, are they the same? And then I'm going to start radiating outwards. Okay, so now if this is the case, what we're going to do is we are going to, for each time, we are going to, here was another observation that I made. Okay, so how do I increase current longest? How do you increase it? Do I do current longest plus equals 1? Well, that doesn't make any sense because think about it. I'm radiating outwards like this. This left is moving and this right is moving. Observation. The pointers can either, this one can be fixed and this one moves and then the length is increasing, or this one can be fixed this one can be fixed and this one moves and that's 1, or both of them can move and that's 1. Or sorry, that's 2. That's 2. That's increasing length of 2. So how do you increase it? Well, do you just say plus equals 2? Oh, we hit a problem here as well. Darn. What's the problem? Well, notice when I have both of them on the same side, it's going to hit this case here. Everything is going to be good, and then I'm going to come here and increase it to 2, but it's not actually at 2. It's here. It's 1, right? Well, here's a fun observation. Notice that left and right pointers, that's an index in an array, and that index itself encodes data of the length. What I mean is, for example, and this was a really cool observation. Like, let's say that we're starting here at the B, okay? Left is here, right is here. What is our length? Well, it's like right minus left. Okay, and then if our left is here and our right is here, so we have right minus left, that gives us the length right there. Oh, okay, that's really cool. So I don't even need a length. Or I don't need to do like, sorry, not current longest, but current length. So what I'm going to do is, what I meant was current length, not current longest. Now I do need current longest. So if current longest is smaller than the current length, And notice we're not doing current length. We are doing right minus left. So I'm checking the length here. I don't need those parentheses, but I'm just making it more clear. Okay. So if that is the case, because here we know that we hit a palindrome, so then left and right encode within them the size of that palindrome. So if this is the case, what do we want to do? We just found that a new longer palindrome. So we need to update both of these variables. So what is the current longest? It is right minus left. It's that. What is the current word? Well, how do we do this? Well, let's just do slicing. It is S, our string, okay, sliced by, oops, come on, sliced by what? And this is one of those things that I need to make sure that I keep my head thinking, right? Like, what is it? It is, we're starting where? Starting at left, okay, and then are we, this is inclusive, right? So inclusive first element, non-inclusive last element. So now how do I wrap my head around this? The way that I thought about it was, okay, and I don't know if I'm actually even saying this correctly. We're gonna figure that out later, but I'm thinking if I look at the last element, so let's say that we're looking at something like this where S is equal to like BB, right? Here. And then this is 0 and this is 1. So I want this 1 to be included in the string, right? And so my right is going to be at 1. And I want that to be included. So we actually, and because this is non-inclusive, I want right plus 1. I think that's correct, okay? And then we're going to just come back up here, iterate through this I again, and then we're going to go and radiate outwards for each letter, like that. Now, notice here we have a problem that what if each time I said that we were radiating out, we start at the same letter? Well, notice how this is always going to be odd. 1, 3, right? Size of 3, because there's 1 in the middle and then 2 out here. 3, 5. It's always odd. How do we get the even ones? Well, we need to start not together, but one apart. Neighbors. So we need to do the exact same thing that we just did here, but we need to have neighbors. So do the even case. All right, so let's try to think about this. And think about the edge cases. Okay. So left is going to be, I'm going to move left over by 1. Okay, so left is going to be I minus 1, and right is going to be equal to I. Okay? So now when I is 0, this is going to be, left is going to be -1, and this is not going to hit. And so we're not going to have to worry about that. Then we're going to come back up here. I is going to be 1, and then this is going to be 0, okay, which is fine. And this is going to be 1, which is exactly what we want. And so this is both within the bounds of the array. And if we find something larger, we check the size, and we should be good. let's return current word, and then we just return that string. Okay, let's see. Oh, I need to update left and right, don't I? Yeah, so that's not gonna work. So once I check if it is, once I check if I found a palindrome, I need to change left and right. I need to radiate outward. So how do we do that? Left, and left is going to the left. So we minus equals 1, and right plus equals 1. Okay, same thing down here. Right there. Left minus equals 1, right plus equals 1. Okay, let's try it again. So this is like if it's at the same element, this is technically going to have a size of 0, but I want it to have a size of 1, right? So I think what we need to do is plus 1. Plus 1. Is that correct? So it's here, and then what if it is here, like if it's at the even case? If it's at the even case, this is going to be 0 and this is going to be 1, right? We're at index 0 and index 1. So 1 minus 0 is 1, and we want it to be 2, so we need to increase it by 1. Okay. Come on. All right, so back to the thing of I'm not going to be going and trying to waste a whole bunch of time. We are going straight into GPT, and we're going to figure out what's going on. Entire palindrome length. Okay, so this is also needs to include that, right? Plus 1, and this one plus 1. Is that the problem? Okay, initialize causes issue if the string has 1 character long. This means nothing is stored. The function should always at least 1 valid character. Okay. Even length palindromes should begin 2 adjacent characters, not 1. Okay, so we might need to look into that. I'm just going to see, did this solve it, or is ChatGPT just too overpowered and it just always gets everything right? Oh, no, okay. So, bam, we solved this problem. So our problem here was that I needed to increase the length in this one as well, in that check, because this is our length, and I set it correctly when I was doing this, but I just didn't update it there as well. Okay, so that's one problem. Let's go to the next one. What did we learn from this, right? Like, try to gain as much as we can. Strings are arrays, and this was a type of problem that we can use 2-pointers on, and there was a relationship between each of the elements, right? Like, is this equal to this? That's what I mean by relationship between two elements. Um, and then those off by one errors, as I said, like I need to review that and make sure that I know about it. And I, okay, well, a useful tip for understanding and processing should I add a 1 here or not is, okay, I break it down into a very simple thing of just 2. And then I can look, okay, well, my index is 0, my index is 1, and then how does that work? So that's a useful tip that I can do to try to understand and get the right answer on those off by 1 kind of questions that I have. Okay, let's come here. Number 11. Let's get a sip of water, though, first. All right. Number 11. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of I are I of 0 and I of height of I. Find two lines that together with the x-axis form a container such that the container contains the most water. Okay. Return the maximum amount of water a container can store. Okay, so what do I notice about this? It's an array. So I have an array of height. And each of the elements in array, each of these numbers correspond to a height. And what is volume? Volume is a relationship between two of those points, right? Like the volume between this 1, or this index 0, and this index, whatever this is, let's just say it's 8, right? Here, well, the volume is actually going to depend on two things: the height and the width. Of what? Of two indexes, right? I actually don't even care about the rest of these numbers. I only care about two indices at a time. So I'm each time I'm only looking at two indices, and all of the information is found within those two indices. The width is their distance apart. Their height is going to be the height of this one and the height of this one. 2 pointers. Okay, see, I'm trying to read the problem, understand how I can know that it's 2 pointers, understand the fundamental types of problems that 2 pointers can solve, and then from there, go. All right, well, what is the actual relationship? Well, the relationship of volume is or technically in this case it's area, right? But it is going to be width, which is going to be the length or distance between the 2 points that I'm looking at, and it is going to be the height of the lowest element. Okay, so how do we do this problem? Well, one of the observations that you can make is that to maximize the height, you want to maximize the width. You want to have the width highest. So what does that indicate to me? I know that I'm going to be using 2 pointers. Well, I don't want it radiating out. I want it radiating inwards, right? Because I want to start with the largest height. And then now, if I want to move my pointer, let's say that I have my one pointer here at 0 and my one pointer here. I said that this is index number 8. I don't know if it actually is. But anyways, 0 and 8. Which one should I move? Should I move both of them? Well, no, because I want my width to stay as large as possible for as long as possible. So which one should I move? Should I move this one? Well, no, because this height is not limiting the width for these two. I should move the height, which is, or the bar, which is limiting the height here. So I move from here to here and then recalculate to see if I have a larger area or volume. I don't like calling it volume, it's area. It's two-dimensional, okay? All right, so then I come here and I find, well, should I move this one or this one? Well, this is the limiting height, so I'm going to move it here. Notice I didn't get larger, I actually got smaller on this one. Well, I say, okay, well then I'm going to move it again and move it here. And now I check the area again, and then if they're both equal height, it doesn't matter which one I move, so I can just move that here, and now it's lower, and I keep looking to see until I get to the point where I'm looking at the same bar. Now, one of the questions is, how can I, just thinking about it, like, how can I know that, like, how do I know that I didn't need to check each, like, starting here and radiate outwards, like that, starting here and then radiating outwards, starting here and then radiating outwards, starting here and radiating outwards, to see which one is the largest? How do I know that it's kind of inherent in the problem? It's, or like, where's the connection that I can start here? I understand that it's the maximum width, but by just decrease or getting rid of the limiting one, I always hit a combination that has a maximum. Like, there's a max when it's here and here, but how do I know that I'll always hit that max? Because I know the answer, I know that it's true, but it's something I don't intuitively believe, which indicates to me that I need to study it more. So let's just go and try to get this question. So current, what do we want? Max area is equal to 0. Okay. So now I want to initialize my pointers at the end of the poles. So left is equal to 0, and right is going to be equal to, is it length of height? Or is it length of height minus 1? So what is right? Right is an index. Okay. Right is an index, and length returns the number of elements. So let's say that there is just 2 elements. So here and here, okay? So again, remember, as I said in the last problem, shrink it down to as small a problem as I can think of and see about those edge cases. 0 and 1, okay? Index 0, index 1. I want my right pointer to be pointing at this one, okay? So I do length of here, which is equal to what? It's going to be equal to 2 because there's 2 elements in here. But I want my right to be pointing at 1, so it's going to be length minus 1. Okay. Now, okay, I want to continue until they are on top of each other. So, while left is less than right, and they're equal to each other, I don't want to do it anymore. What do? We say if area is greater than max area, then we update. So let's find area. What is area equal to? It is equal to the width times the height. Okay, well, what is width? Width is going to be equal to the distance between the two pointers. Well, we just figured out how to do the distance, right? Like, that was the last problem. It was right minus left, and then it was plus 1, right? Okay, awesome. Notice that was a hesitation that I just did. Let's think about it, and let's really get these concepts hammered out. So we have left here, right here. What should the distance be in this case? Well, the distance actually should be 1. So 0, or 1 minus 0. That one. So hold on. This one, we don't do a plus 1. Why do we do a plus 1 here in this distance? Well, let's think about it. Well, in this problem, and by the way, I'm thinking about it real time right now. I don't know the answer. I think I've looking at this, I think I have a pathway. But this is not something that I wrote down in my notebook when I was first solving it. I just realized this problem right now. I think what's going on is here, I don't want this element and this element. I don't want to know how many poles I have. I want to know the distance between them, right? This distance. How many areas between them? That's fundamentally different than this problem, where I wanted to know how many elements are in there, right? How many indexes, not how many spaces between the index. Okay, so that's a difference. See, and if I didn't know about that, that would have thrown me off and thrown me off and thrown me off, and I would always be like, oh, is it this one or is it that one? Is it this, right? But now, because I've articulated it, I'm able to, next time I see it, I will have a better understanding. And if I get punched in the face again and I have that problem, I'll be like, oh, I remember this. I struggled with this, and then eventually I'll be able to get it. Okay, so cool. We got that. So width and height. So what is height going to be? Well, we have to do the height of the limiting pole. So it is the minimum of height of left and height of right. So whichever one is smaller, that's going to be our height. Now, are both of these inside the bounds of the array? Well, according to here, this starts at the last index here, and this starts at the first index here, and then we stop when they're equal to each other, and the left index is never going to move over. It's not radiating outwards. It's not going to move over by 1 to the left. It's only going to move rightwards. Likewise, my left index is never going to move to the right. It's never going to go out here. It's always going to go inwards. So this one is going to come this way, and then it would stop here. Or this one is going to come inwards, and it stops here. They're always going to meet somewhere in the middle. So we don't need to worry about index outside the bounds of the array. So, okay. Now, what happens if the area is larger? We need to update max area. Max area is equal to area. Okay. Then we want to move. Do we want to move both of them? No, we just want to move the limiting pole. So if height of left is less than height of right, what do? We want to move the lower one. So left, how do we want left to move? We want it to move this way. So left plus equals 1, else, and notice if they're equal to each other, it doesn't matter which one moves. Just pick one. I'm going to do the right one. Or if the right one is the limiting one, we do right minus equals 1. Okay. Then we keep doing that until they're equal to each other, and then we return max area. Let's see if that works. Oh, it doesn't like this. Why? Height is not. There we go. Three, 4, 5. Int. They should all be integers, right? Does it do the test cases? Or is it just grumpy about everything on this line? Int object has no attribute get item. Alright, well, you know where we're going. Assigned an integer. Okay, this isn't troubleshooting time. This is just trying to get the algorithm time. Reassigns height to an. Oh, that's because this is called height. That's so stupid of me. What is this going to be called? I don't know. Something. Something. Okay. Okay. Maybe I should have done the run, but okay, cool. There we go. We got it. Okay. What I was doing is I was reassigning this height array to an integer. So here's an integer, right? It was awesome. Do I have any water? I have almost no water left. All right, let's move to the next one. Do we want to do threesome or threesome closest, or okay, we're not doing this one because this one I didn't. That one wasn't one of my problems. So, threesome. Okay, so threesome. Let's read it. Given an integer array nums, return all the triplets, nums of I, nums of j, nums of k, such that I does not equal j, I does not equal k, and j does not equal k. And nums of I plus nums of j plus nums of k is equal to 0. Okay, notice that the solution set must not contain duplicate triplets. So, first thing to know is I can definitely feel that I'm starting to get pretty tired. We'll struggle through this one. Okay, so first thing to notice is instead of just having 2 pointers, I now can have 3. So I can use the 2 pointers methodology of solving problems to check not only the relationship between 2 elements, but 3 elements. Okay. Now the trick to this one, I remember first off, we need to sort the array. And the reason that we need to do that is so that we don't have duplicates. And why that helps is I'm able to have an array, kind of like whatever, like nums is equal to like this, and it's I don't know, -5, -4, -4, -1, 1, 3, 3, 3, 4. So I can start here. I have 1 pointer here, 1 pointer here, and 1 pointer here. So then I do these 2 pointers and I kind of radiate inwards. And I radiate inwards. Again, noticing back to patterns that we had in the past. Radiating outwards or radiating inwards, or what are we doing? We're radiating inwards. And why are we doing that? Because I have information that if I have a 4 here and a -4 here, and I'm larger, like the sum of my 3 numbers, again, sum of 3 numbers, what does that mean? That I'm checking the relationship between 3 numbers, and I have the 3 pointers. But if that relationship is too big, well, I know that I can decrease it by moving this pointer over by 1 to the left. If it's too small, I can increase it by moving here over by 1. And then I notice that these 2 are the same, so that I can move it over again. And now I need it sorted because I'm going to keep moving over here by 1, and I want to be able to check my neighbor. Because if I'm not able to check my neighbor, I might include duplicates. And I need to, again, articulate it to myself better why sorting will make sure that I don't have duplicates. I kind of know it, like I know something. I'm not just memorizing that part. I understand it kind of. The contains water one, I don't intuitively understand. I don't like that one doesn't make sense. Not that it doesn't make sense, but I just don't feel that at all. This one, I kind of feel that it makes sense. I just don't know how to articulate it. Okay. So let's start coding it. So I'm gonna have P1 is going to be equal to what? 0. It starts at the first element. P2 is going to be equal to 1, and P3 is going to be equal to the last element. So length of nums, and then because this is an index, -1. So I didn't even need to think about it this time. I knew, it's P3 is an index, nums is an array, length gives me how many elements. I don't want how many elements, I want how many, or the last index. So I didn't even need to think about it. So now what I'm going to do is I'm going to move this pointer over by 1 each iteration. So for what? I don't know yet. In nums. Okay. And then I need to perform to sum. Okay. That's radiating inwards, and I have these two. So while P2 is less than P3, then when they're together, I don't want to do that because I can't add the same number twice. That doesn't make any sense. I can't do like -5, -5 because they're the same number. I can't draw the same thing from SAC twice. Okay, so what do I want to do? I want to have a case if current sum is equal to nums of P1 plus nums of P2 plus nums of P3. Okay, now if current sum is larger than 0, and 0 is kind of like our target. In this case, what do we want to do? The current sum is too big, so we want to decrease it. So I'm going to go P3 minus equals 1. Okay. Else if, nope, this is Python, elif current sum is less than 0. In this case, it's too small and I need to increase it from the left side. So P2 plus equals 1. Okay. Else, they're equal to each other. In this case, what do I want to do? I want to add that to my answer. So answer is equal to an empty list. Answer dot append. What do I want to append? I want to append a list of these ones. All right. Okay. Then I need to move P1 or P2. Which one should I move? Yeah, that's a good question, actually. Which one should I move? Well, if P1, so if this current sum is equal to 0 already, if I move P2 over, it's going to be I guess do I just need to pick one? I was thinking like does that mean that I've exhausted all of the combinations for P1 is at the like first index, but I don't think so, because I can have like -4 and 4 here, and then I can have like -3 and and positive 3, which is another combination. So no, I do need to move 1 over. So, and then I remember I needed to move it over and check if the next one. So here's another thing, like, okay, this problem teaches me a new skill, which is moving over until you're not next to your neighbor. And I remember you have to, there was something tricky about it. I can't remember what tripped me up. But when I did it last time, there was something that tripped me up. I wrote about it in my notebook. What is it? So I need to do another while loop. So while I'm going to be, I don't know if I need to move P1 or P2. Maybe I just need to move both of them. I think it will actually take care of it if I just move over one of them. So while I'm going to do P3 is greater than P2. So P2 is going to be set in place, and that's kind of my bound. So I know that I'm not going to go outside the bounds of the array. So while this is the case, and okay, so I need to move P2 or P3 over by 1. So P3 plus equals 1. No, minus equals 1. Okay, so I already moved P3 over. Now I need to check if, hey, me is equal to the one that I just moved from. Okay. And nums of P3, so my current location, is equal to nums of P3 plus 1. Now, I can guarantee that this is inside the bounds of the array because P3 was just inside the bounds of the array. I decreased it by 1, and now I'm just increasing it by 1 again. So I'm just going back to the original spot that I was just looking. Okay? So while this is the case, I'm going to keep decreasing P3. So P3 minus equals 1. Okay? Plus equals 1. Do I need to do a while loop for every single one? I think I do. Darn. Okay, so I'm just going to copy and paste this and change it to the way that I want it. So now I'm moving P2. So let's see. Well, P2 is smaller than P3. So P3 is my bound. I'm going that way. I think it actually would have worked if I just left it there, but I just want to say it this way. So P3 is my upper bound, and P2 is going to be moving. Then I increase P2 by 1, right? And I check if P2 is equal to the value that I just came from, minus 1. And I guarantee that that's within because P1 was just in the bounds of the array. Okay. Then what do I want to do? I want to keep increasing P2 until they're not equal to each other. Okay. So I just decreased P3 by 1. P3 is going to be, so while P3 is greater than P2, okay, so P3 is going to be going down and P2 is going to be kind of the blocker, the making sure I'm inside the bounds. and P3 is the number that I'm currently at is equal to the number that I was just at, then I want to keep decreasing P3. Okay, that makes sense. And then I need, okay, so this actually needs to be while. So while while P1 is less than length of nums, okay, and that's not correct yet. So P1 is going to, I'm going to keep going with P1, and if we have here that P1 is right here, and then I do my 2 pointers, I don't want to do another 4 because that's going to cause a duplicate. I want to keep moving P1 over. Now, think about the case where P1 is here, P2 is here, P3 is here. I actually don't want to move ever P1 here because that kind of like squishes the other two, and that you can't do that. So, well, P1 is less than nums of here minus what? Okay, well, this length is going to give me the number of elements. So let's just make it simple again. Nums is equal to here 0, 1, 2. Kind of like that. Okay. So how much is nums going to be? This length of the nums. It's going to be 1, 2, 3. Okay. So I want to stop when P1 is equal to 0, right? So, or sorry, I want it to run when P1 is equal to 0. I do want that case. So I believe I want 2, right? So this is going to be equal to 3, and that's valid. But then 3 and P1 is equal to 0. So 3 minus 2 is going to be the 1. But then this is not equal to, so it's 0 is less than 1. And then next time it hits, P1 is going to be equal to 1. And then 3 minus 2, okay? So we still have the same number. 1 is not less than 1. Okay. Just gonna do this. Okay. Now I realized I actually can't set these two right there. The reason is because each time I do a loop, I need to reset my 2 pointers. So P2 is equal to what? Is equal to P1, but plus 1. So it's the next one over. P3 is going to be equal to what? It is going to be equal to the last index. So it is length of nums minus 1. Okay? And then here, this will, if we have like a empty array or something like that, this will not hit because these conditions kind of block it. And then at the very end, I need to do another while loop, right? here to keep changing P1 over. So while P1 is less than length of nums, that's what I called it, yep, and nums of P1 is equal to nums of P1 minus 1, so the one that I was just previously at, and I need to change that. So P1 plus equals 1, so I'm moving P1 over by 1, and now I'm checking if my current location is equal to the location that I just came from, but I'm also checking the upper bound, like I don't want to keep moving until I go all the way off. Okay. Then what do? I say P1 plus equals 1. Okay. Now I should be able to return answer, right? Answer. I'm going to see if I got syntax errors here wrong. Okay. Oh, I didn't sort, by the way. I just realized that. Okay, so nums.sort. Okay, there we go. That was the problem. Obviously, if we don't sort it, it's not going to work. Okay, and then there we go. All right, so I think I am going to head to bed. But we had a very successful day, actually. So we were able to hit a bunch of problems, and I feel much more confident now doing these problems than I did initially. So I'm hoping that this method is going to work. I'm going to keep trying to do this method. I'm going to see and document my progress if this does work. And I think it also does provide a lot of value to people if they're trying to see a whole bunch of problems and to hear the observations that I'm making and try to maybe you have some uh, gaps in your conceptual knowledge just like I do, right? And so trying to find those gaps, that's where it's really difficult. Find out what's causing confusion. And that's why I'm journaling my thing while I'm going through these problems. And so, yeah, I will continue to be working on this method for doing Leetcode, seeing if it is effective, seeing the results, documenting the process, and hopefully it is also beneficial for everyone watching as well. If you do like these videos, subscribe because as I just said, I'm going to be making a ton more videos. I do both Leetcode and also projects. So I do a whole bunch of projects trying to improve skills and specifically doing projects to build skills that I think are extremely important in software engineering, specifically back-end software engineering. So if any of that seems interesting, subscribe. And I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you in the next video. Have a good day. Can't wait to get to sleep.